Algebra 2, Section 5.4, we're dealing with complex numbers. So these complex numbers include square roots. Now before we can go into the square roots, we've got to review some of the properties that you went over in Algebra 1, and then some new ones. So what happens here is the two main rules for square roots is that if you have two numbers multiplied together under the square root, you can actually separate them and put them in their own square root box, radical box. Same thing goes with if they're dividing, then you can put the square root on top only and square root on the bottom. And you'll see in the examples why that's beneficial to you, because if, let's see, b is a perfect square and a is not, then at least you could square root b and leave a in its radical. Now, whenever I have something x squared equals n, okay, and I would need to square root both sides, then my answer is going to be plus or minus that number. What that means is, if I'm going to square root 16, then my answer is going to be plus or minus 4. It means in order to get 16, I can do 4 times 4, or in order to do 16, I can do negative 4 times negative 4. This is our imaginary numbers. If you don't remember where imaginary numbers come from, they come from a negative in a radical. So for example, if I have negative 16, right, this is the same thing as saying square root of 16i, okay? Because that negative then comes out as I, and then square root of 16 is plus or minus 4i. Now, whenever I have an I squared, okay, so if I have I times I, then it equals a negative 1. It actually equals a real number instead of just an imaginary number. So, here's an example of that. This is an example of this. Go ahead and pause this and write it down, and we should be ready to do some example problems. Alright, so here we're going to go ahead and simplify all of these, and each of them are going to take different rules, but it's okay, we'll take them one step at a time. The first one is square root of 28. Now, with that negative in there, as you remembered, a negative is the same thing as an I, negative square root. So this is the same thing as saying 28i. 28 is also the same thing as 4 times 7, if I factor it out, right? And the reason why I chose 4 times 7 is because then, according to the first rule, I can separate them. Negative square root 4 times square root 7i. Well, square root 4 is a perfect square, so that means I can take it out and it not be a decimal. Square root 4 is the same thing as plus or minus 2 root 7i. And that's my answer. Because square root 7 cannot be square rooted anymore, and we have to keep the I, and plus or minus is there. So to simplify, square root negative 28 is the same thing as saying plus or minus 2 square root 7i. Right, let's move on to the next one. The next one has variables in it. And this is, we're going to go ahead and take out the I. Put the I right out here, so we're going to have 32. Now 32 is the same thing as saying 16 times 2, okay? Or I can do 4 times 4 times 2. Whatever it may be, I'm going to break this down, okay, to its prime. 4 times 4 times 2. So, and this is the same thing as saying y times y times y. I'm going to go ahead and take out pairs. When I have the square root here, it's telling me that the only way I can take them out is if I have a pair that lets it exit the radical. So for example, I have a pair of 4s, so that means I can take out 1 4. I don't have a pair of 2s, so I can't take that out. I have a pair of y's, so I can take out 1 y, and it gives me the square root, all that's left over. Well, I have a 2 that's left over, and I have a y that's left over, so they stay in the radical, and then I. And so here's my answer. So basically, I'm just merely trying to take out pairs. Once I have a pair, I can take out 1 on the outside of the radical. It's like currency. Every 2 inside the radical equals 1 outside the radical. My next one is dealing with i's. Now with i's, I just treat them kind of like x's, how I multiply and divide them. So I have negative 3i times 2i gives me negative 6i squared, because I times I is squared. Okay? It'd be the same thing if I did negative 3x times 2x. I'd still get negative 6x squared. So it's very similar. Except this I squared, if you remember from the properties, equals negative 1. So it's the same thing as saying negative 6 times negative 1, which would be positive 6. And that's my answer. Right? Because negative 6 times negative 1, a negative and a negative make a positive. Now, my next one is I have these two radicals in here, so these two in here, and I'm going to take out the radicals. So I'm going to end up with 12i times 2i. I can combine them to make 12 times 2, and the i's times together gives me I squared. Alright? So again, I'm taking out pairs. So I have 4 times 3 times 2. This is 4 is the same thing as saying 2 times 2, I squared. Okay? So I have a pair of 2's here, so I can take 1, 2 out, but 3 and 2, I can't take either of those out because they don't have a pair, so that gives me 6 in there. And then I squared is the same thing as saying negative 1. So my answer is negative 2 root 6. Right? And just a footnote, this 4, I can still say this would be 2 times 2 times 2 times 2. So then I'd have 2 sets of 2's that I could bring out, which then ultimately gives me 4. So whichever way that you would like to do it. So go ahead and try page 264, numbers 4 and 6, page 264, numbers 4 and 6, and see if you can get them. And I'll see you in class.